Skywalker, Vader, Leia, Vader's Leia. So. Oh wait, that's like vulgar. And then there's Leia. Yeah, I mean in my heart I agree. So.
Here we go. If you know of anybody that would like to adopt a dog, let me know. Okay. So we're in our notes 3.4, which is at the very bottom of the back of page 26. We are going to start learning, or reviewing, because you did this last year, how to combine logarithms. So when we have more than one logarithm in an expression, it is generally a good idea to put them together. So I'm going to help you remember a couple of rules that are going to help us.
Yeah, it's the last question.
We're going to get these things put together. All right, so here's the whole section, the whole problem. We're going to stick these together. Here are the rules. When two logarithms have been subtracted, that means the numbers themselves have been divided. So our job is to write one logarithm, not two, one. Since these are subtracted, it means x and y have been divided. So that's the rule. That's the rule. When a log is subtracted by another log, it means the numbers themselves were divided. So you take the two logarithms, you make them one, and that becomes a quotient. Okay? Now, I'm going to skip down. I should have labeled these. I'm going to skip to E. Because E is two logarithms, but this time they are added. Well, wait a minute. If when they're subtracted, I make a division, when they're added, I'm going to make it a multiplication. So this is going to go together into one logarithm, and the number that goes in here is going to be 28. X times y, 4 times 7. Your job in this part of the notes is to make one logarithm. If they are subtracted, when you make them one, you turn the problem into a division. If they are added, you turn it into a multiplication. Okay? So let's look at the one right under that. Let's look at F. I'm going to make this one logarithm, so I'm going to write log. Now what's going to be in the parentheses? 2. Because it's 16 divided by 8. X divided by y. What about G? Now don't panic. What's ln? Isn't ln a logarithm?
Yeah, 2.
Yeah. So that's just going to be ln 19 over 8.
Yeah.
19 over 8 doesn't reduce, so we'll just leave it 19 over 8. If it did reduce, we would reduce it. It's always a good idea for this part. Okay. Now, all the rest of our problems have an added complication. Like, let's come back to this one. I see that. Doesn't that mean I'm going to be multiplying?
Yeah, so
But there's something else in the problem.
2 times 1.
There's this guy out here, right?
Yeah.
Now, what do we do with that? I got a whole bunch of them in these problems. What do we do with a coefficient? Well, this is your next rule to know. 3 rules. First one is when it's a subtraction, it turns into a division. When it's an addition, it turns into a multiplication. And the third rule is if you have a coefficient, it becomes an exponent. So that 2 turns this into x squared. Coefficients become exponents on the thing that they're hooked to. So the 2 is hooked to the log x, so that 2 becomes an exponent on x. So now I have the log of x squared plus the log of y. What is that going to go together as? I'm going to put it together, 1 logarithm. What's going to go inside here? That's an addition. X squared y. Don't I multiply them?
Oh, yeah.
That's an addition. When you put them together, you put them together as a times problem. Now, is this one gonna go together as a times problem?
Yeah.
Yep.
It's gonna be
But
negative.
first, I have to take care of this. Where does d go? Exponent on z. So I have the log of z to the 1/3 plus the log of w. So now I'm gonna write 1 logarithm. Here I have 2, I'm gonna make it 1. And then what's gonna happen to the z to the 1/3 and the w? Multiply. Z to the 1/3 times w. Now this one up here, letter D, has a lot going on. What is the first thing we're gonna have to deal with in letter D?
You have to put the 4 in the x and the y.
The 4 is gonna be an exponent right here. And the 3 is gonna be an exponent right here. So I'm gonna have the log of xy to the 4th minus the log of x cubed. No more coefficients. The coefficients become exponents. What do I do with log minus log? I put it together and it becomes a division. Now, as Brian said, that 4 goes with the x and the y. Would you agree with that? That 4 goes with both? So now I have this. I have an x to the 4th and a y to the 4th over the x cubed. Does that simplify?
Yeah.
Yeah.
Log x y to the 4th.
Very good. That's it exactly. Because 3 of these cancel with all but 1 of those. Good job. What's left? Just the last one?
H.
H? Alright, let's look at H. What do I have to do first?
Move it to the
3 in the
Move the 3 and the 1/2. So the 3 is gonna move here. And the 1/2 is gonna move here.
Would you actually square the 2?
So I'm gonna have ln, let's look at it, Brian. I have ln 2 cubed plus ln 36 to the 1/2. ln follows the same rules because ln is a logarithm. It's just a different kind of logarithm. So all the same rules apply.
Multiply.
So before I multiply, I am gonna multiply, but before I do, what about 2 cubed? What's 2 cubed?
8.
8? Let's just make that an 8. And what about 36 to the 1/2? What's a fractional exponent?
A negative.
Oh.
A radical?
Alright.
And that's the square root. So that's just 6. So I have ln 8 plus ln 6. I'm gonna put that together and make it ln 48. 8 times 6. Right? Okay. Now, let's look at the next set of problems because they are opposite. So in other words, now we're gonna take them apart. Everything we did up here was taking 2 logarithms and putting them into one. Look at problem A, 2A. It says ln xy. There's 1 logarithm. You're gonna turn it into 2. You're gonna have an ln x and an ln y. You're breaking it apart, expanding it. All right? What are you gonna put in between them? I know I have an ln x,
Addition.
I know I have an ln y. What's gonna go in between them?
Addition.
An addition. Why is an addition going between them?
Addition
Because
is.
that's a multiply.
Addition is.
It's the opposite of the rule we just talked about. When it's an addition, it goes together as a multiplication. So if it's a multiplication, it comes apart as an addition. Okay, so what about the next one?
Log x minus log y.
Yeah, that one's gonna be log x, log y, those are your 2 logarithms, and you're gonna put a minus in between because it's a division problem. All right, let's look at the next one now.
It's 3 log x minus 4 log y.
You are exactly right. So if that makes sense to you, if you've got that, awesome. If you don't, let's walk through it here. First of all, would you agree this is gonna be a subtraction problem?
Yes.
So it's gonna be the log of x cubed, the log of the top, minus the log of the bottom. But now I got these powers. Where do those powers go?
The coefficient.
Out in front as a coefficient. So 3 log x
Why would you
minus
move
4
it?
log y. That's exactly what he said. A minute ago, you had something that looked like that, and you put it together. Now you're taking it apart. Okay, D. Logarithms and radicals do not get along, so we need to change that radical into what? What is a radical? A fractional exponent. So we're gonna rewrite this as the log of xy to the 1/5. Everybody remember that 5th root is a 1/5 power? Now where's that power gonna end up? Where do powers end up? Out front, coefficients. So 1/5 log xy. I gotta break that apart. What does this look like when I break it apart? Log x plus log y. Now, does that 1/5, I put like parentheses, does that 1/5 go with the whole thing?
No.
Are both of these under the radical? Then don't both of them get the 1/5? So you can go ahead, you can leave it like this, or you can go ahead and distribute the 1/5, if that makes more sense to you. They both are under the radical. X and Y are both under the radical, so they both are going to have the 1/5. Compare that to the next problem. Do you see a division? So, when I look at this, I immediately think, okay, I'm gonna have the log of the top minus the log of the bottom. Does that make sense? Now, logarithms and radicals do not coexist, so this has to be changed. What is that going to be changed into? X to the 1/4. And then where is the 1/4 going to end up? Out in front. So far, so good? I think we're done. Notice that the 1/4 is only hooked to the X, because in the original problem, the only thing under the radical was the X. As opposed to this problem where they were both under the radical, so they both ended up with a 1/5. Now, the last two problems are the challenge problems. These are a little bit harder. Let's see if we can fight our way through them. What's going on in between the 100 and the x squared? What's going on there? That's a multiply. So when I pull this apart, it's going to be the log of 100 plus the log of x squared. Would you agree with that? And then where does this 2 go? Out front of what? Just that, right? So we have the log of 100 plus 2 log x. This guy comes out in front.
The 100 wouldn't move.
What do you mean it wouldn't move?
It wouldn't go, never mind, it's not this side. So I thought it was square root second.
Now, we're not done with this yet, because this guy right here simplifies. This goes back to what we did yesterday, and I know we covered a lot yesterday, and your heads were spinning. So let's think about this for a minute. What's the base right here? 10. What do we know about 100? It's 10 squared. And so what is the log base 10 of 10 squared? Remember your properties. What is that? Isn't that just 2? So the answer, final answer, is this right here. Yesterday we did quite a few problems like this, where if those two numbers match, that's the answer. Now, the only reason I could do that is because that was 100. If that had been a 90, I couldn't do it. But it's 10 squared, so I could do it. That's tricky, that's hard. Probably won't be a test question unless you make me mad. All right, here's another one, just like it, okay? Just like it. We're gonna start by splitting that into ln 30 and ln e cubed. Look at that first and make sure that makes sense to you before we start doing the tricky part. Okay, now ln 30, there's nothing to do with that, so that's gonna stay the same. But what does ln stand for again? Log base e. What is the log base e of e cubed? That's just 3. So your answer is ln 30 plus 3. I can't remember if I told you this yesterday or not, but something that's kind of helpful to remember is every time, anytime that you have an LN and an E directly touching each other, there's nothing in between, like there's no radical in between, there's no X in between, it's just an LN and an E touching each other, they are inverses, so they are gonna cancel out. That happens every time. An LN and an E touch, they cancel. So that's kind of helpful to remember. Okay. All right, now we need our calculators. And those of you that invested in the new calculator, you have a huge advantage over those of us with the old ones, but it's okay, because Lord knows I've lived almost 67 years with a calculator that didn't do base whatever logarithms. You can do it. But remember, on your calculator are 2 logarithm buttons. Right? Everybody's calculator has 2 logarithm buttons. What are they?
Log
Their log, which is base 10, and their ln, which is base e, right? So when we have a problem that says log base 3 of 4, we are not going to be able to use those 2 buttons because it's a base 3. And our calculator doesn't do base 3. Unless, and again, these are the kids with the newer calculators, if you go to your math, menu, so your math button, and you click all the way down, you find a button that says log base. Keep clicking down. If you have this calculator, keep clicking down. Find that one. And when you press enter, it gives you the ability, gives you some boxes, doesn't it? It gives you a box here and a box here. Fill them in and tell me what you get. Now, those of you with my calculator, I'm going to show you how to do it. It's going to be easy, but you're going to have to press more buttons. What did you get? 2618? 2618? All right, so you guys with the skinny calculators, did everybody get that? Okay. All right, now, I want everybody to do something with me. Those of you with the skinny calculators will never have to do this again, but I want everybody to walk through it with me. It's really, really easy. A way that you can use the regular buttons on the calculator to evaluate this is to think of it as log 4 over log 3. So log of the top, I call it the top number, the big number 4, over log of the bottom number. Go ahead and type that in. Be careful, you gotta close the parentheses after the 4. So type log 4, close parentheses, divided by log 3. And guess what happened? What did we come up with? Same answer. So, everybody can do this problem on your calculator. Some of you will do it by filling in boxes, and some of you will do it this way. Remember, if you're doing it this way, it's the log of the top over the log of the bottom. Okay? So, with that in mind, I want you to do the rest of that section. Compare notes with your partner. Answers.
This word, that's long for it, 2619.
Oh, I took his word for it. It is 19. Last time I listened to Mr. Lee. Okay, go ahead and do the rest,
Good job on that.
the rest of them, however your calculator functions.
Does it matter which number you put first?
What do you mean?
Like, for like A, what, does it matter if I put 4 first or 3 first? Like, it doesn't matter.
Definitely not talking
You have to do, it has to be log, are you doing it like this?
Yeah.
It has to be top number or bottom number.
Okay.
Has to be.
I definitely, I don't need, I don't have to.
Everybody's typing this
So
in.
you divide the number on the bottom by the number on the top? What do you divide? No.
We're rounding to the 10,000, so please watch your rounding.
Is that just an accident? Oh, 0.4?
Yeah. All right, I need somebody to come up and write the answers on the board for us. You can do them all or just one of them, I don't care. We need to get them all up on the board. So we can decide if we know what we're doing.
Okay, I like that.
You can do
Oh.
B, or whatever you do. Oh, never mind.
What do you guys decide with respect to race? What do you guys decide with?
I know it's funny, but what is we
Wait, no, I didn't. Never mind. Wait, what?
You're singing yours?
Wait.
I don't think you're singing. Stop breathing. Stop breathing is not cool like that. The alternate version. I can see it. Start to
Wait,
I don't know. I was thinking you're singing.
I did not get that.
I know it's funny,
I got a 0. Maybe I put it wrong.
it's like.
I take my shirt off. Bro.
Oh wait, yeah, I definitely have
Guys, we should not be having rounding issues. Look, write the number down. 711919. All right, now how many decimal places do we want? 4. So 1, 2, 3, 4. Right? See, you write it down and look at it. There's no question.
Receive.
It's
It's 0.4.
Oh, 0.4. Am I the only one who got 0.88? What'd you get? I got a B. So what'd you get? Chase, how'd you do B?
Wait, see, what'd you put? E? 1.795. Yeah.
Well,
I think you're around.
yeah, long hair.
See, but they got 1.2.
All right, we have all the answers up here. Now we have to decide if they're right or not. So, however you did it on your calculator, for problem B, did you get 1.2323?
Yeah.
How'd you?
2, 3.
So did I. What did you get?
I got 0.88007.
Here, we typed it in.
I did log 7 times.
Use parentheses.
Yeah.
Log 7. No.
No, it's log.
Log 11 divided
Then
by log 7.
Okay, I didn't know what it was.
Brian, Maria asked that question.
What?
Does order matter?
Oh,
Then I answered her,
oh,
okay?
alright.
So that's what happens when you're talking to your friends. Don't do it. Listen. Lock in.
I got the same answer, I don't know why.
Log 11, close the parentheses,
Divided, okay.
divided by log 7.
You just typed in the exact same thing.
All right, for problem C, whoever did this got negative 2.7119?
Yeah.
Yep. Yep, that was right, that's a 0.4, that's a 0.4 in the problem. D, whoever did this, 0.3263?
Yeah.
E, 1.7959? And F, 6.4919. Okay, so that'll be a test question. You'll just straight type it in, however you do it on your calculator. There's no work that you have to show for that. It's just, can you type it in on your calculator? All right, now, part 4 here, these are a couple of word problems. And I'm going to abbreviate this a little bit. We have a formula given in the problem. Oops. The formula looks like this. All right, now, the good news is you do not have to create this formula. It is given to you, okay? This is a formula, according to the book, for the intensity of light, X feet under the water in Lake Erie. Okay? All that's given to you. You don't have to do anything. You just have to know how to use this formula. So this is the intensity. This is the depth of the water. Okay? You know, especially in some place like Lake Erie, the farther down you go, the less light there is, right? And this is a formula that gives that. Now here's your job. Your job is to find I if X is 10 feet. So in other words, you're gonna find the intensity 10 feet down, okay? So what do you think we're gonna do? Here's our formula. What do you think we're gonna do?
It'd be 10 over 12. If I is 10, then you plug in 12.
X is 10. X is 10.
Oh,
Is it
X
X
is
10?
So you put 10 on the end.
So we're gonna put 10 in there. So we're gonna have the log of I over 12 equals negative 0.00235 times 10. Now, I can type that into my calculator, or since it's times 10, I can just do it, negative 0.0235. But you've got a calculator, you can go ahead and type it in, if you want. Now, this looks terrible, but you actually did a problem like this yesterday.
Multiply 12, doesn't it?
what is the base on this logarithm? 10. So I am going to loop-de-loo this equation because I can't solve it with a logarithm out there. So when I loop-de-loo, remember how that works, that's a critical piece of stuff for you to know. I'm gonna write 10 to the negative 0.0235 power. And that is gonna equal I over 12. So always start with your base. And to this number equals this number. That loop-de-loo motion. Okay? Now, can I figure that out on my calculator? So I'm gonna figure that out, and then what am I gonna have to do to get I by itself? Multiply 12. So let's go ahead and figure out this number. 10 raised to the negative 0.0235 power. Did you get 0.947? Okay, times it by 12. And the answer is 11.37. If we round it off to the 100th.
Why don't we have to, make 10, 1/10 since the.
We can, so if you do that, if you do 1 divided by 10 raised to the positive 0.0235, you get exactly the same number. Your calculator can handle negative exponents. So you don't, if you're typing it in on your calculator, just type it in. If you'd rather change it, you can. It'll come out the same way. All right, everybody get 11.37 when you did that? The key to doing that problem is right here. You can't solve the I can't solve the problem. Nobody can solve the problem if you got a logarithm in it. So you gotta get rid of the logarithm. And how do you get rid of the logarithm? You loop-de-loo. Because as soon as you do that, there's no more logarithms. Okay? Use your exponent right here. All right. Next problem. This one involves earthquakes. But you don't really need to know that because they give you the formula. Here's the formula you're going to use. And they want you to find R. And they're telling you that A is 250, T is 2, and B is 4.5. Do not make this hard. What are you going to do? Plug in all those numbers. So when I plug in all those numbers, I'm going to have the log of 250 over 2 plus 4.5. Now, 250 over 2 is what, 125? I'm just going to type that in on my calculator. I have the log button. I'll just press log 125. Make sure you close those parentheses. Plus 4.5. What'd you get as your answer?
6.651 7. I mean, I'm just rounding. I was just rounding. So I was rounding.
Okay, let's look at
I was rounding it.
Right, here's the number, right?
I was rounding it up.
You said you're 10.
Alright, here's what we get now. Let's say we're gonna round to the 100th. Okay? The 100th would be right here, right? Right? That's a 59 right there, right? That number's bigger than 5, so that's gonna go up, right? It's gonna go up to a 60, so it's gonna be 6.60. If you round to the 100, if we were rounding to the 1,000, then that is gonna cause that to go up. So 6.597 if we're going to 1,000. If we're going to the 10,000, it would just stay that way, so 6.5969. Okay. What? Okay, now what we're gonna do here, we have a couple more minutes. What we're gonna do is a couple of review problems. I think, oh shoot, when do I see you again?
Monday.
I don't see you till Monday? Then I see you Tuesday?
Yeah.
Okay. So we'll do a practice quiz next time and a quiz then on Tuesday. So what will be on the quiz? Well, not everything. Tell me about this. Log base 7 of 49. Can anybody tell me what that equals?
2.
Oh, no calculator. Get off that calculator. This is a no calculator.
7 times 7 is 49.
Why does it equal 2?
Because 7 times 7.
Because, well, look, is 7 squared 49?
Yes, ma'am.
Yeah. This is the log base 7 of 7 squared. Of course it is.
That's 3. That's an easy question.
All right, how about this one? What about
Number Kinsey. Yeah.
a little bit harder? What do you think about that one?
Maybe 1
1/2. 1/2, because this is the log base 10 of 10 to the 1/2, isn't it? Guys, we really have to be able to move back and forth between radicals and exponents. A square root is a 1/2 power, always. Okay, both ways. So if you have a 1/2 power, you have a square root. If you have a square root, you have a 1/2 power. So the answer to this problem is 1/2. Okay? Another one. How about 18 to the log base 18 of 6? That's 6. Because when those two match, the answer is that. Be paying attention. All right, couple more. Don't say it out loud. I want everybody to try these two on your own. Log base 3 of 27 and the log base 2 of 1/4. Don't say it out loud. Everybody try those two, and then we'll see if you get them right or not. Yeah, they're easy. They're all easy. .4 homework will be due on Monday, by the way. 3.4 will be due on Monday. Okay. Hope you did this without a calculator, because the quiz will be no calculator.
Do the quiz on Monday?
What did you get for this one?
3. What did it be?
You got
Oh, wait.
3.
Yeah, this is 3 cubed. So the answer is 3, right?
Yeah.
What did you get for this one?
Negative.
-2.
Got Trey Bob.
2 to what power is 1/4? One
Yup.
is 1 over 2 squared. 1 over means negative,
Yeah.
right?
Well, I don't think my calculator tries it.
You got 0 out.
What? Hey, y'all boys gonna what's it called? Y'all boys gonna keep fight?
No, sir.
You said no, sir?
I'm not playing. Me or Armani not playing.
Y'all didn't guys say it. Hell, my cousin, please drop anybody off the stage.
In your homework, the problem looks like this, something like this. And it says put them together. So it's gonna go together as a division, would you agree with that? And the base is 4. That doesn't make any difference, that doesn't change a thing. The base can be whatever the base is, it just shows up in the answer. Alright, yep.
Hey, I'm telling you, bro, I'm taking me and my cousin against the world, bro. Come on, man.
I want to take you against the world, and that's